Okay, so this isn't so much calculus here as a quick review of inverses, and it's something you've done probably several times. But there's one major point I kind of want to hammer home. If you're taking a look at the points on a function, and by the way, these are taken straight from your notes. Look up the notes on the topic page. They're all going to be there. You can see the exact same thing. If you pick out any point that's on an original function, like 5, -2, we know that on the inverse function, there will be a point at -2, 5. All you have to do is switch the x and the y coordinates. You know that the inverse switches the x and the y. On the graphs, likewise, if you reflect something across the line y equals x, that gives you the graph of the inverse function. And by the way, when you reflect something across that line, it switches the x and y coordinates. This point right here at 2, 1 will also have a point at 1, 2 on its inverse function. So once again, we're switching the x and the y. Almost there, folks. We also can look at the equations and, oh, wow, it's a miracle. Yes, when you want to find the equation for an inverse function, you switch the x's and the y's. I'm not going to go through that one again because we're not doing that at the moment. But I just want you to notice that inverses will switch the x and the y values to get points, to get the equation, or to get the graph. But here's what I really want to look at. This is the calculus part, and it's pretty simple. If we were to look at the slope on any of these graphs, so if I pick out a specific function here, and I find there's a point 10, 4, and the slope happens to be a rise of 1 and a run of 3, so the slope's 1/3 here. On that corresponding point on its inverse function, if this point was 10, 4, the corresponding point is at 4, 10. The slope's going to be the reciprocal, 3/1. The slope's 1/3 here, and the slope's 3 on its inverse function. They must be at corresponding points. Same thing over here, and unfortunately, they're the same numbers. We have a slope of 1/3 and 3, but at different points. We have 6, 2, and the corresponding point on its inverse, 2, 6. That is the major rule there for inverse functions and derivatives. That's all we're going to need to know. Let's take a look at how some of the examples might look on an AP exam. This is exactly what a multiple choice AP problem might look like. I know that because I stole this directly from a multiple choice AP test. And this is actually considered one of the harder problems on there. But there's one quick way around this. If you can recognize that these are inverse functions and write down a few quick steps, you'll be in good shape. So here's what you might try and do. As soon as you see their inverses, I want you to look for this. If we have a point at 10, 2 for the g function, or the inverse, what point must be at the original function? Hopefully you got my meaning earlier when I said, remember that you just switch the x's and y's. Now it's asking us for the derivative of g, but we don't have a g function, so that seems awkward. Here's what you need to remember. If you know the derivative of f, meaning you can actually find the derivative of f at any point, maybe at the point where x equals 2. Well, now what can we do with that? Because I said there was only one calculus portion you needed to remember about inverses. The main thing you need to remember, the main thing is that you switch the x's and the y values when dealing with these inverse functions. That's for regular inverses. The only thing you need to remember about the calculus part is that the slopes are just reciprocals of each other. So while I don't know what the derivative of g is, I do know what the derivative at the corresponding point will be. This one's at 2, this one's at 10. And it's just going to be the reciprocal. These are actually quite easy if you can identify that they are inverses and you know to switch the x's and y's. And you also know to take the reciprocal. These are quite simple functions. I'll probably give you a couple of them as practice. Good luck.